So we are really good at finding bugs, security vulnerabilities, and optimizations in code. And one of the ways we try to demonstrate that is by giving a very clear risk reversal guarantee on our service. Essentially, if we can't find 7 bugs, security vulnerabilities, or major optimizations in your code base, we'll give you a full refund on the cost of getting us to sit down and do that analysis. And I wanted to take the opportunity while I've got your attention to talk about that, because it's not just a marketing ploy, and it's not something that we offer just to get you on the hook. It's because it's statistically impossible that you've caught all of your issues. And I think that if you let us into your code base, we are going to find a lot more than that. And if you can give me 5 minutes, I'd like to explain why that is, and more importantly, what you can do about it. Now, I want to be very clear that I'm not trying to come in here as a smug vendor and tell you that your software is simple. I'm not trying to say that your engineering team isn't incredibly talented. Building great software is one of the hardest things on this planet. It takes constant firefighting, deep domain knowledge, and it has a humongous cognitive debt that has to be paid in order for people to understand exactly what's going on. What I do want to say though is that every software testing methodology used in modern software is fundamentally flawed. Unit testing, integration testing, fuzzing, property-based testing, deterministic systems testing, even formal proofs. Every single technique you could possibly be using does not work at scale and cannot prove software is safe or correct. I'll get into the proof of this in a moment, but I want to be realistic about this first. It's very unlikely that your engineers are actually using formal proofs, fuzzing, or deterministic systems testing on a daily basis. If that is you, that's insanely cool, but you still haven't covered off every possible risk. Most companies are only doing unit testing and integrations testing. And if that's you, it does mean that production is your ultimate testing ground. Unit integration tests are at best psychological security blankets. They give just enough confidence to hit deploy and pass the bug, which is why almost everyone is treating their customers as an unpaid quality assurance team. And there are major economic reasons for doing it like this. And the biggest is that even the very expensive and very time-intensive techniques still don't work. To prove software is correct, you have to do 3 fundamental things. The first thing is proving that the abstract intent is correct. And what I mean by this is proving that the architecture and the design makes logical business sense, that it doesn't break the rules and policies that your business is trying to emulate and trying to simulate. The second is the physical code. We have to prove that the physical code runs locally without any side effects or any unexpected hidden states. The third is the execution environment. We have to prove that when this code is running on servers and interacting with databases and dealing with third-party libraries, that it can handle all of that gracefully, again, without hidden states or side effects. If you took a collective catalog of every possible testing technique you could use to ensure software quality, it is fundamentally true that none of them cover all of these areas. Unit testing, for example, only tests what the developer has already assumed could go wrong. They're monuments to confirmation bias. Fuzzing has issues where you cannot assert a property that you cannot conceptualize. Formal proofs mathematically prove that your software is correct, but they don't actually understand the intent behind that software. And it's very easy to prove something is correct, even if it's completely off the mark in the abstract intent you're trying to implement. Likewise, the maths assumes a sterile environment. It works in a vacuum. There are no techniques that cover the abstract intent, the physical code, and the execution environment. And you could argue that layering is the solution here, but layering doesn't work because the cost curve is so exponential of doing this that it's just fundamentally impossible for a business to do this and make money. Writing formal proofs takes 10 to 100 times longer than writing actual code and requires a tremendous amount of expertise. And the worst part is, if your business requirements change, you will have to redo a lot of this work. Formal proofs, fuzzing, property-based testing all require a lot of maintenance, and it drops your velocity to a very slow pace because you're now saddled with this technical debt of maintaining this very complicated testing suite. Because doing all of this is an economic death sentence, most teams make the rational choice. They write basic unit tests and integrations tests, they catch any obvious stuff, and then they accept that there's going to be massive blind spots, and they push to production anyway. Nearly everyone in our industry is accepting the bug tax as a cost of doing business. Now, there is another angle of this that I think is pretty important for us to talk about, and it's that human beings will probably never write great code. And it's debatable whether large language models will either. Let's look at the physical reality of how developers work. It's trapped in the file-by-file perspective. They open an IDE, they look at 100 lines of code in an isolated file, and they try to just make that work. It's a very localized and highly focused perspective. Bugs, security leaks, and performance bottlenecks do not live in single files. They live in the blank space between files. They are the emergent property of whole systems interacting at once. We expect engineers to mentally calculate how a small change in file A will affect file B under a database lock when it's under high load, while in file C, a packet is dropped. Human beings only have about 7 slots of working memory, while your application has potentially millions of state trajectories. It's a complete biological mismatch, and this is the reason that we do testing, but it's also part of the structural trap of testing. A developer cannot write an automated test for something that they cannot think about. You simply cannot write an assertion for a hazard you cannot conceptualize. I really like this quote by Albert Einstein. You cannot solve problems by using the same type of thinking you used when you created them. Tests as they are currently conceptualized and executed fall under all the same constraints as writing software. And this is exactly why your code base right now is horribly exposed. It is why I am so confident that if you let us into your code base, we can really help you. I've spent a large amount of my life thinking about this exact problem, and I think I have a really good solution now. It's better than Fable or Mythos, it's better than any pen tester, it's much faster than both, and it's much cheaper on a unit cost level. I emphasize unit cost here because it means that this technique can be scaled to your entire code base, which functionally tools like Mythos and Fable cannot do. Not to mention these tools are still stuck in the file-by-file analysis viewpoint. We currently offer a simplified, easy-to-use version of this as a SaaS product. But the reason we're offering this now as a done-for-you service is because this is really just the tip of the iceberg of what can be done to ensure your software's quality and safety. When you work with us directly, we can customize and configure this toolkit in a way that is just not practical for an off-the-shelf solution. We pair you with an experienced engineer that knows how to configure, run, and interpret Dev in a Box to find the deepest defects in your system. Working one-on-one gives us the opportunity to confidently drop false positives to zero, to hand you ready-to-merge fixes, and to deploy a whole set of tools and techniques that we just cannot do with the SaaS product. One of the things I'm most proud of is that we can actually give you hard metrics on code and state space coverage against risk reduction. We can also ratchet up the intensity, which is just not practical to do unless you're working with someone one-on-one. If you're interested, working with us is really easy. We just need access to your code and some basic facts about your tech stack. We use a service called Tinfoil to do all of the LLM inference. This means that all of your source code and all of your intellectual property is never exposed to a third-party service while doing this analysis. We will also sign an NDA to protect your privacy as much as possible. We also, as part of the service, give you 12 months of free access to the Dev in a Box SaaS. We do this so that your engineers can start to use it to catch bugs and defects before they go to production. The SaaS uses customer-controlled encryption, which means that you actually control the keys for the database, not us, which gives you complete privacy even when it's running on the SaaS. If you talk to us, we'll also host this on a private server for you. The reason we give you access to the SaaS is because we think it's the most practical way for you to get the benefits of our toolkit and also build a long-term engineering culture that prevents defects from going to production. It's much better for us to demonstrate the value of the tool to your engineers and all of its power before we try to push it on them and get them to use it. Now, we're not asking for blind trust here. All of our fee is directly tied to performance. If we don't find 7 high-value defects or major optimizations, you pay absolutely nothing. We believe that code quality is a completely solvable problem. You do not have to pick between shipping fast or shipping broken code. Let us help you by absorbing the engineering cost of bugs, help you protect your valuation, and help you reach 0 defects in your code base. Thanks for watching.